Welcome. In the previous lecture, there was a mistake in this part of the derivative. Okay, so if we differentiate 1 by s minus 2 first time, it will give minus 1 by s minus 2 whole square, like d ds s minus 2 to the power minus 1. So it will give minus 1 s minus 2 minus 1 minus 1, so minus 1 by s minus 2 whole square. Okay, so in that way, or in this way, and for the second time derivative it will give 2 by s minus 2 whole cube, and for the third time it will give minus 3 by s minus 2 whole to the power 4. Okay, so accordingly this will be plus. Okay, so thank you. Now we will see Laplace transformation of integrals. So property 4, Laplace transform of integral. Okay, so if L of f of t equals f of s, then L of 0 to t we will use f of u instead of f of t. Since the limit of integration is from 0 to t, it will be f of s by s. Okay, like example, Laplace transformation of e to the power, say, at by t. Sorry, it is division by t, not this problem. Right, Laplace transformation of 0 to t, say 1 minus sin u plus 2 e to the power 3u du equals to what? Okay, so this belongs to the Laplace transform of integral property. So we can write f of u equals 1 minus sin u plus 2 e to the power 3u. Now apply Laplace transformation f of u 1 minus sin u plus 2 e to the power 3u. This will be f of s. It is not necessary that the f of this function, for this function of the integral must be in the form of, in the function of t, but it can be the function of f of u, f of x, or any kind except t. And if after applying the Laplace transform, we will get the similar thing. Okay, so for 1 it will be 1 minus 1 by s, and for sine it will be 1 by s square plus 1, since the coefficient of u is 1. Okay, and for e to the power 3u it will be s minus 3, and these two constant. This is our f of s. Okay, and for this our answer will be Laplace of 0 to t, we can write f of u du. This will be f of s by s, or we can write 1 by s into 1 by s, 1 by s square plus 1 plus 2 by s minus 3. So something like this. Okay, now property 5, it is called division by t. Okay, so if L of f of t equals f of s, then Laplace transformation of f of t by t, it will be s to infinity small f of u du, or you can write f of x dx, no matter. Okay, like example, Laplace transformation of say e to the power okay, we can write e to the power minus say twice t by t. It's a very simple example. Okay, this equals to what? So comparing the property, we can write f of t equals e to the power minus twice t, and f of t is Laplace transformation, that is f of s equals 1 by s plus 2. Okay, so it is this form. I think it should be taken in the form e to the power minus 3t minus e to the power minus twice t. Okay, so it will be, otherwise it will not converse, e to the power minus 3t so for this is minus 3t minus e to the power minus twice t, and from this we will get, this is s plus 3 minus 1 by s plus 2. Hope you have understood. Okay. So therefore Laplace transformation of f of t by t, this will be s to infinity small f of u. So we will have to write this in the form u plus 3 1 by u plus 2, it will be du. Now we'll have to evaluate this integral. Okay, since we know integration 1 by x dx means ln x, so you can write ln u plus 3 and here minus ln u plus 2. Our limit is s to infinity, so ln a minus ln b, it becomes ln u plus 3 by ln u plus 2, so s to infinity. Okay, now we will have to work over it, something like if we put infinity here, so it will be infinity. So now we will remove infinity by taking u as common, 1 plus 3 by u, if we take common 1 plus 2 by u, limit s to infinity. Okay, I am turning the page. Okay, so it will be ln 1 plus 3 by u by 1 plus 2 by u, and u cancels each other, so it's s to infinity. So now if we put the lower and upper limit, we will get ln 1 plus 3 by infinity 1 plus 2 by infinity minus ln 1 plus 3 by s 1 plus 2 by s, and this becomes 1 plus 0 1 plus 0, as we know something by infinity means 0, so ln, and this will give s plus 3 s plus 2. If we make LCM, s of the numerator and denominator will cancel each other. Now this becomes ln 1 ln s plus 3 by s plus 2. So ln 1 means 0, and we can write ln s plus 3 s plus 2 power negative 1. So we can remove this negative by reversing the numerator and denominator like this. Okay, so this is the required transform. Okay, now we have only one left. That is, we already have wrote 5. That is the sixth transformation, that is called the Laplace transformation of derivative. Okay, number 6, Laplace transform of derivative. Okay, number 1, if, or say I, L of f of t equals f of s, then L of f prime of t, this will be s f of s minus capital F of 0. Like 2, if L of f of t equals f of s, then f double prime of t, I mean second derivative, it will be s square f of s minus s f of 0 minus f prime of 0. Okay, so this formula in this way, for the third derivative, I just write down the third derivative, L of f triple prime of t, it will be s cube f of s square f of 0 minus s f prime of 0 minus s to the power 0, I mean it will be f double prime of 0. So in this way, for L of fn of t, we get the general formula s to the power n f of s minus s to the power n minus 1 f of 0 minus s to the power n minus 2 f prime of 0, and in this way the last term becomes negative f of n minus 1 of 0. Okay, this is the formula of derivative, and we can't show you the application of this example of these formulas, but we will use these formulas while solving the differential equation. Okay, so these are the formulas. Now you will have to practice some problems regarding these properties. Okay, thank you.